Hi everybody, welcome back as we continue through the worksheet Thermodynamics in Chemistry 1. I've decided to put together problems 4 and 5 here because they both deal with a similar kind of a problem setup. Problem 4 on the left shows that an unknown metal absorbs 61 joules of heat and its temperature increases by 29 degrees Celsius. And they ask us what is the heat capacity of the metal. The formula for heat capacity is it's usually represented by a C. It's going to be the heat divided by the temperature change. So it's going to have units of something like joules per degree Celsius or calories per degree Celsius or something like that. The second part of this, problem 5, gives us a similar setup. So some chunk of metal absorbs some amount of heat, 1800 joules here, and its temperature changes by some amount, in this case 22 degrees, but the problem also tells us that the metal has a mass of 120 grams, and it asks us for specific heat. So specific heat is very much the same kind of a setup as heat capacity, but it is specific to the mass of the metal. So when we say specific heat, it's really heat capacity per gram. And I want to kind of just throw out a general disclaimer here that depending on who wrote your book, what country it was written in, and in what decade, these terms might be look slightly different. So heat capacity does not depend on mass. Heat capacity is just the amount of energy it takes to change temperature by a degree. So we get the formula on the left. Specific heat or specific heat capacity will be heat per gram per degree. You'll also find these numbers sometimes in terms of moles. And in particular, I want to point out that the letter C will sometimes be stylized differently. So sometimes a capital C, sometimes a lowercase c. Sometimes it'll have a subscript P to indicate that it's being done at a constant pressure. So I don't want to sort of bog down in the details too much, just to say that heat capacity doesn't require mass. Specific heat does. So the math here is actually pretty straightforward. I'm going to come over here to the left first and just say I've got 61 joules of energy, 29 degrees change. And so when I do that math and I just go 61 divided by 29, I get 2.1 and some other decimal points. Since I have two significant figures in each of my numbers, I'm going to just stop right there. And notice that the units are complex units, 2.1 joules per degree Celsius. Okay. On the other side, specific heat now is the same kind of a deal. So here, 1800 joules per mass is 120 grams, and temperature change is 22 degrees. And so I'm going to get the same kind of math here, 1800 divided by 120 and divide again by 22. I'm going to get 0.68 and then 18 repeating. That's kind of a cool looking number. Notice my units here, joules per gram degree Celsius. And so again, from a significant figures standpoint, all three numbers they gave me had two significant figures. And so I would round this, and that's kind of sad. I lose my repeating number, but that's okay. 0.68 joules per gram degree Celsius. All right, so the point of this video and putting these two side by side is just to say, notice the difference in terminology. Heat capacity will have units of energy per degree. So joules or calories on the top, degrees on the bottom. Specific heat will be similar, energy per gram degree or energy per mole degree, depending on what kind of unit you're using. All right, so that's problems 4 and 5. Check out another video for problem 6 and keep up the good work.